Welcome back, everybody. Second, let me let some people in. Have a little bit of a technical problem, but I think I got it fixed. All right. Okay. Couple of things. Actually, one. All right. Right now, early in the semester, everybody's about in the same spot with respect to assignments. So, and it's easy when I get a question to determine which assignment you are talking about. However, once we progress, in fact, I'm seeing it now, it's being spread out. Some people are jumping ahead and doing some of the work early, which is great. Okay, all assignments are open. You're welcome, especially in the labs, to jump ahead and knock them out. Okay, but do give me the question, or excuse me, give me the assignment and the question so I can actually go hunt it down and find out what the problem is. Okay. And obviously, if your answer is correct, I'd have no problem giving you giving you your points. And then the other aspect is email. My EDU email, I get a ton of email from Maricopa. I get them both from SEC and GCC and so forth. And so if you use the EDU email, your email to contact me, it might get lost with all the tons of stuff I get. Canvas email, I get nothing but email from you guys. I get nobody else. Okay. So do use Canvas email if you want to communicate with me. And that way I can be assured that I will at least get your question answered and not get lost in the 10,000 billion emails I get from EDU email address. Okay. All right. Any questions, comments, concerns? A week from today would be the first exam, correct? Everybody is aware of that. It'll be chapters 1 to 3. We'll be done with chapter 2 today. We'll jump into 3 and then knock that out on Thursday. Okay. A reminder that if some homeworks are due before we get done with the chapter, remember that's not the case. I may have just not moved the due date. Don't get too concerned. I will fix it. Point being that I will not make an assignment due until we're done with that particular chapter. Okay. All right. Except for the labs are, they're set up. Go for it. Let me see. Any questions before I continue? No. Okay. Well, let us continue with the chapter and where we're at. We were done with, I believe, we stopped on slide 16. We were talking about significant figures. Let me just rehash. Now, the important aspect about significant figures, I want you to remember, all the numbers are significant, okay? They are worth some type of value. We remember that. We're not talking about it's insignificant so we can throw it out. No, we're not doing that. We are talking about presenting your data, presenting your answer, no more accurate than the least accurate means of measuring whatever you measure, okay? We all have seen you type in some numbers in a calculator and you got 15, 20 digits, okay? Well, just because you got 15, 20 digits does not mean that's a very accurate number. In fact, it's the opposite because you're really governed with respect to the accuracy of your measurement method. And you can't really present something that's more accurate than the least accurate value. Okay, so we've been talking about significant figures so we can determine how many digits eventually to give our answer. Okay, and there were some rules that we went through, and really the rules can be broken down very straightforward. One, all integers are significant, point blank, that's it. Numbers 1 through 9, of course, they're significant. Where the trouble comes into the confusion are the zeros, okay? And Thing about the zeros, if the zeros are between two integers, they count as being significant. Now, all the other digits tend to have a bit of a problem or confusion, I should say. And all you got to do is ask yourself two questions. And if you answer yes to both of those questions, those zeros are significant. Question number one, with respect to zeros, other than zeros that are captive by integers, but all the other example zeros. Is there an integer in front of that zero? If you answer yes, then move on to the next question. The next question is there a decimal point anywhere in that number? If the answer is yes to both those questions, that zero is significant. Okay, so try that with those examples there with other than the ones that are trapped between two integers, which we know it's a given, okay, but everything else. That tells us how many significant figures a number has, which would then allow us to determine how many significant figures our answer will have, because we're obviously going to take these numbers and we're going to do some mathematical function. Nothing complicated. We're going to multiply or divide it, or we're going to add or subtract it. That's it. Okay. All right. So we talked about the rules there, and then we talked about exact numbers. These are numbers that are exact. For example, you counting a number of people, 14. Well, we have exactly 14 people, not 14.2 or anything less, 13 and a half. It's an exact number. So exact numbers are not used in determining the number of significant digits your answer would have, okay? Also included in this list would be the atomic weights. I briefly talked about that. That's that number below the symbol on the periodic table. Those are the atomic weights of the elements. Those digits would not be used to determine the significant figures in your final answer. Now, there are a couple of other things I'll talk here in a second. Numbers that are not exact, just keep in mind, did I measure this thing? And if you measured it and it's not exact, then it would be a factor. So if you measure something 7 inches, something weighed 200 pounds or kilograms or whatever, 10 ounces or 10 milliliters, those are measurements. And with respect to any measurement, okay, there always that last digit, whatever decimal number is, there's a degree of uncertainty. There's no measurement out there in the world that is 100%. There's always a degree of uncertainty. Obviously, you want to make that degree of uncertainty less, as small as possible, but that always, sometimes that you can't do it. All right, so anything that is measured, again, is not exact. Now, let me briefly go to the periodic table. And in the shapes table, let's get to this. In the shapes table, we give you a lot of information in the shapes table, but we give you 3 pieces of information. Okay. Let me highlight them. They're conversion factors. Okay. The first one is 1 inch is equal to 2.54 centimeters. Okay, so that is a conversion factor for measurement of length. For weight, going from metric to English, we give you a second conversion factor. 1 pound is equal to 454 grams. And then for volume, going from English to metric or metric to English, 1 quart is equal to 946 milliliters. Now, when you start converting from metric to English, and you're going to go either length, mass, or volume, use these conversion factors. Yes, I know there's a ton of other conversion factors out there. Again, a lot of numbers. Now, the key point about these 3, the first one, which I should have given a different color, is this one right here, is considered exact. Okay, by convention, even though it's a measurement, by convention, 1 inch is equal to 2.54 centimeters. is considered an exact number, therefore is not used in the conversion or in the determination of significant digits. Okay. The other two in red are measurements and therefore could be a factor when you are converting from pounds to grams. You can see that one, obviously the number one is an exact number. It's 1 pound. However, the 454 grams is a measurement. Okay. So that has 3 significant digits. 1 quart, the number one is an exact, but the other 946 milliliters is a measurement. Okay, and it has three significant digits. So they could be a factor in determining a final answer with the correct number of sig figs. Okay, keep in mind here, you see, notice this 1 inch is equal to 2.54. You can write that one or two ways. All conversion factors, all ratios can be written by just simply inverting the numerator with the denominator. Okay, and we're going to get into a method of how we can utilize this by keeping track of your units when we set up the problems, and by keeping track of units and making sure things cancel out properly. Like I stated, 99%, you would set that problem up right. I can't give you the full 1% of one extra 1% because you control the calculator. Okay. All right. So remember that it might come up in homework problems with respect to sig figs and you're using these conversion factors. All right, let me go back to the. All right, so we got exact numbers. Now, let's take a look at these digits here. And we have to determine how many sig figs are in each one, okay? So we got 5.05. How many sig figs, significant figures, does that number have? Well, obviously the 5s are the integers, so they count. Now you've got the 0. Well, you have two things you can do here. You can remember that any zeros that are trapped between integers are significant. But if you forget that, ask yourself those two questions. Okay, for that 0, is there an integer in front of the 0? And the answer is yes, there's a 5. Okay, so that's true. And then is there a decimal point anywhere in that number? And again, the answer is yes. So therefore, the 0 counts. Therefore, we have 3 significant figures. Okay, 1,200. Okay, again, the 1 and the 2 count. Now the question is the zeros. Okay. Same question. Is there an integer in front of those zeros? Answer is yes. Okay. Second question. Is there a decimal point anywhere in that number? Answer is no. Therefore, those 2 zeros do not count as significant with respect to significant figures. Therefore, we only have 2 sig figs. Okay. Now the third one, same setup here. You can remember the rule that leading zeros is a number less than 1. So those leading zeros do not count. They're just telling us what decimal point they're at. They're a decimal point holder. But again, for the 2 leading zeros, ask yourself the same question. Okay. Is there an integer in front of those 2 leading zeros? Answer is no. Therefore, you don't have to go any further. They don't count. The 0 between the 2's, obviously, is between 2 integers, okay? And therefore would count. But again, if you forget, there is an integer in front of the 0 between the 2's, and there's a decimal point, okay, in that number. Therefore, that 0 between the 2's counts. And same scenario with the last 0. And there's an integer in front of the last 0, and then there's a decimal point in that number. Therefore, we have a total of 4 significant figures, okay? 4 sig figs. And so we have this one, this one, and this one. That's the 4 significant figures. That one and that one for the 1 and 2 in previous number. The 0.0, those are leading zeros and do not count as being significant. The next one, 0.0005, we know that the leading zeros don't count, and therefore that number only has one sig fig, okay? Now we have 50, okay? 50 has, anybody want to take a guess on that? No, don't have to guess, just use the rules. And that would be correct. We have 1, either 1. No, only 1, Anita. Again, ask the zeros. Oh, Skylar, I got your email. I'll send you an email back when we get done concerning your question. Okay, if we look at that 50, okay, the 5 is an integer and therefore counts. The 0, again, is there an integer in front of it? Yes. Okay. Is there a decimal point in the number 50? No. Therefore, that 0 is not considered significant. Okay. It is considered significant with respect to value. We're talking about 50, but is not considered significant with respect to significant digits. Okay. So there's only 1 in 50. Now, the whole ball game changes when you put a decimal point and then you start adding zeros, because now for all those 3 zeros, there's an integer in front of all those 3 zeros for the next one. Okay. And there's a decimal point in that number. Does it make a difference where it's at? There's a decimal point in that number. So what does that mean? That number 50.00 has 4 significant figures. Okay. And then this one here, 123.45, those are all integers. Automatically, they all count. And they're all significant. So we have a total of 5. Okay. Then finally, the last one, 8,090. Okay, the first 0 in between the 8 and the 9, trapped between the 2 integers, so automatically counts, no question about that. Second, the last 0 after the 9, yes, there's an integer in front of it, but no, there's no decimal point in it. Therefore, that last 0 does not count. And we have 3 sig figs. Now, we need to learn the number of significant figures, okay? Because when we multiply and divide, take a note, when we multiply and divide these numbers, then the answer would be no more sig figs than the least accurate number. And you think about it, if you look at the 2 examples, 5.05, okay, versus 1200, yes, that number 1200 is much bigger, but it's not as accurate as the 5.05. Okay, that 5.05 is measured to two decimal places. The 1200 did not measure. You know, that true answer can be anywhere from 13 to 1100. That margin there is fairly large. Whereas 5.05, the true value could be anywhere from 5.06 to 5.04. So that error is much smaller. So if we were to multiply the first 2 digits or divide the first 2 digits, okay, then our answer would have no more than 2 sig figs. Let me repeat that. If we were going to either multiply or divide these 2 numbers with each other, okay, then our answer would have no more than 2 significant figures in the final answer. You can multiply that answer and you'll get a bunch of digits, but we cannot have more than 2 significant figures. And we're going to do some examples of that. The same is true with respect to the next set. If we were to multiply this number with this number or divide those 2 numbers with each other, our answer cannot have no more than 1 sig fig, because the 1 the 0.0005 has the least number of sig figs. Okay. Similar with the next pair, 50 and 50.00. Our answer could have no more than 1 sig fig. And then if we look at the last two pair, and we're going to multiply and divide these two numbers here, okay? Multiply or divide. I emphasize what we're doing here mathematically. I'll multiply and divide. Then our answer would have no more than 3 sig figs. Okay? All right. When we add and subtract, it'll be a little bit different. We're going to look at decimal places, okay? We'll get some examples of that. All right, so this flow chart kind of summarizes it for you with respect to determining whether something is significant or not significant. Okay, but basically it's just the question, like the question one asked. Other than remember, if the zero in this plays through the zeros only, because that is the confusing part with respect to sig figs. And the thing about zeros, just remember, if they're in between two integers, they count. That's it. But if they're not, then you ask the question whether is there an integer in front of it, okay? And is there a decimal point in that number anywhere in that number? If the answer is yes to both of those questions, then that zero counts. If the answer is no to any one of those questions, that zero does not count. Okay, so this comes into play in determining how to present our answer. And we're going to talk about rounding, okay? And we're going to round a number. If once we determine what number we're going to do something to with respect to rounding, remember this, that number is either going to stay the same or go up to the next value, okay? It not go down, okay? That number, and I'm going to repeat that again, that number that we're working with, we're going to round, either is going to stay the same or go up to the next value. And that decision is based on the immediate neighbor for that number, not the neighbor that's like 10 digits down the road. We don't care about those numbers down the road, only for the immediate neighbor of that number that we need to round. Okay, because I always get the question, well, what if, I got 10 digits here, but what if I take the last number and I round up that one and it makes the next one round up, which makes the next one round up, and so on down the road till you get to where you're at. No. Okay, we don't care what's happening 100 digits down the road, only to the immediate neighbor of the number that we're going to either round up to the next value or keep the same. And we use the rule of, is it greater or equal to 5? Is the neighbor greater or equal to 5? Okay. So if that neighbor is less than 5, then the example here, 5.4, would remain as 5, and we drop the 0.4. Okay, we'll get some more specifics here. Or if it's that neighbor is greater or equal to 5, we're going to round off as a whole number here. Then that 5.5 gets rounded to 6. Okay. Now, what do we mean about changing the magnitude? Okay. That means the value of that number. For example, down at the bottom, okay, when you look at the number, look at the value, the magnitude of the value. Are you in the thousands or in the hundreds or in the billions or so forth? Look at that value, okay? Because those zeros that are there have to stay there before the decimal point. You maintain that magnitude. For example, it says here, round 5,400 to 1 sig fig, okay? Well, starting from the far left, on the far left, we count 1 sig fig. If we needed 2 sig figs, then it would be the 4. We needed 3 sig figs, it would be the first 0, so on and so forth. So starting in the far left, the 1 sig fig position, I denoted it by the arrow. So then we look at the neighbor, the immediate neighbor, which is a 4. which is much less than 5. Therefore, the number that we're looking at first arrow stays the same. Okay, we don't drop it down to 4. It stays the same. Remember, rounding means that number stays the same or goes up. Therefore, we will drop the 4 and change it to a 0. Okay, and so our number is 5,000. Okay, because 5,400, the magnitude is 5,000. Okay, so our answer has to remain in the 5,000 magnitude. And if we just completely drop the zeros and say, oh, okay, 5 is the answer, well, you are totally incorrect. Imagine this, you want $5,000 or you want $5, okay? And that's what happens when you drop the zeros. And a thing to remember is this, if you have to drop an integer before the decimal point, those get converted to zeros. The numbers after a decimal point get dropped off to nothing. You don't lose magnitude there. We'll do some examples of that here in a bit. Now, I may be sounding redundant, but I'm doing that for a reason because I've seen what's come up, with respect to these numbers. So bear with me. We'll get through it. All right. So here's some numbers. The question being asked is round it out to 3 significant digits or sig fig position. So starting to the far left, from the far left, we count 3 positions. And that's the 3 right there. Okay. Which means that, keep in mind, we're after a decimal point. Okay, be aware of what we're doing here. We're after a decimal point. Okay, Skylar, here's my point before you think about that. And Skylar, you wrote 1.844. Are those zeros significant? Think about it, okay? And the answer would be yes. Yes, those zeros would be significant. So you have 1, 2, 3, 4, 5 sig figs in your answer. Okay, and so here's the thing that I was going to say. After a decimal point, when you gotta drop numbers, you just get rid of them. They fall off. Okay. All right. So we look at the 7, and Skylar, you got the 4 correct because you look at the neighbor. Okay, which is number 7, which then tells you yes is greater than 5. Therefore, the 3 gets bumped up to 4, and so our answer is 1.84. That is 3 sig figs. There you go. If you were to add zeros and not drop them, guess what? Those zeros count. Use the rules of the rules. Look at the zeros. If you were to write 1.8400, there's an integer in front of those 2 zeros, and there's a decimal point in front of those 2 zeros. Therefore, you would have 5 sig figs and not 3. Okay. And the easiest way to remember that is look at where you're truncating the numbers. It's after the decimal point. And like I stated earlier, any numbers that you need to get, you can drop any numbers after that digit that you're working with. Okay. If you're after the decimal point, if you're before the decimal point, you can't drop the zeros. The numbers, you have to add zeros to it, because if you drop those numbers, then you change the magnitude. Okay, let's take a look at this one. $7,162.32. We need to round it to the 3 sig fig position. Far left, we come across through the 3 sig fig position, which is number 6. Okay, we look at the neighbor's 2. It's less than 5. That tells you that the 6 remains a 6. Look at the position of the first 2 right next to the 6. It is before the decimal point. So that 2 becomes a 0. Okay. The numbers 3 and 2 after the decimal point, you can drop them. Okay. And so your answer is 7,160. That is 3 sig figs. If you were to drop that 0, then you end up with 716. Now remember, when you look at the number, find out first, determine what magnitude you're at. What is your magnitude? You're in the 7,000 level. So your answer should remain in the 7,000 level. Okay. Again, would you rather have $7,160 or you want $716? Okay. Notice the magnitude. All right. All right. Here we have these digits. Now remember the lead. Oh, why? Okay. Claudia, good question. The question is this: why not 7160? Let me write that in there, just so everybody can see that. Okay, 7160.00. All right, good question. Good question. All right, how many significant figures does the number 7160.00 have? 3? Are you sure? 4? Are you sure? 6 is good. Skylar, the answer is correct. 6. Okay. Again, look at the 3 zeros. The 0 after all the zeros after the 6. Now ask the question again. Is there an integer in front of those 3 zeros? Answer is yes. Okay. Second question, is there a decimal point anywhere in that number? The answer is yes. What does that tell you about the zeros? That they count. Therefore, you have a total of 6 sig figs. The problem said you want your number to be converted to 3 sig figs. Okay. You have 4 sig figs in the number 7160.00, whereas the number the answer here, you only have 3 sig figs, which is what the question asked one to do. Okay. Does that answer your question? Okay. So the thing to remember, if that number that you're going to truncate, that number, in this case, example number 2, the number we're going to truncate or change anything after was the 6, because the question says 3 significant figures. So we count from the far left and count over to the 3 sig fig position. If the question says 1 sig fig, then the 7 is the position. If it says 2 sig figs, then the first one is the position. See how that works? So that's why I marked it with an arrow, because that signifies where you're going to either keep that number the same or move it up to the next value because you're rounding. Okay. And the way we determine that, we look at the neighbor is greater or less than 5. That tells us whether that number 6 remains 6 or goes up to the next value. The other aspect you need to remember is if there's a number before the decimal point, we convert that number to 0. If there are numbers after the decimal point, you can get rid of them because it doesn't change the magnitude. Don't put zeros back in, because then you end up with that number 7,160.00. And what that does by putting zeros back in with the decimal point, those zeros are significant. Yes. For determining whether that 0, the question, Claudia has that question. So the criteria is whether a decimal is there, not the position of the decimal point. Yes. For determining whether a 0 is significant or not, doesn't make a difference where it is, as long as you've got a decimal point in front anywhere in that number. Okay. And the 2 questions. Is there an integer in front of it? Answer is yes. Is there a decimal point anywhere in that number? Answer is yes. You answer yes to those 2 questions, then those zeros count and they are significant. Okay. All right. Good. All right. Good questions. Let's go to the next one. It's 3. We need, remember, those are leading zeros, so those aren't the 3 sig fig positions. So we go from the first integer after the leading zeros, which is 1, and we count to the third position because we want to go to 3. We want our answer presented in 3 sig figs. This is what you do. Remember earlier I said if I multiply or divide these two numbers, then I should only have 2 sig figs or 3 sig figs. This is what's happening here. This is the result of the multiplication or division of some other numbers. And that the whatever you did mathematically, multiply or divide only, the least accurate has 3 sig figs. So your answer should have no more than 3 sig figs. So you plug in the numbers and you get all these big numbers. And now we got to find it where to truncate it at the 3 sig fig position. That's what we're doing right here. This is the result of the mathematical function of the multiplying or the dividing of numbers, of which one of those numbers, the smallest sig figs, was 3. Okay. All right. So we see that the 1 is where we're going to truncate. So that means we look at the neighbor, which is a 1, which is less than 5. That means that 1 that has the arrow on it remains 1. And now we can drop the 1, 5, and 4. Don't replace it with zeros now, because if you replace it with zeros, what's going to happen? They come significant. That is correct, Skylar. That's your answer. 3 sig figs. If I were to replace the 1, 5, 3 with zeros, guess what? You made those zeros significant now. And now you have 6 sig figs if you replace them with 0. So remember, those numbers, the ones that are going to truncate, the 1, the 5, and the 4, they are after the decimal point. Notice where the decimal point is. So you can just get rid of them. You don't put zeros in there. Drop them. Okay. 24,925. Okay. We locate the 3 sig fig position, which is the 9. Okay. We look at the neighbor, which is 2. It's less than 5. And so then we replace the 2 and the 5 with 0. Okay. Because the 2 and the 5 are before where the decimal point will be. If we simply drop the 2 and the 5, what have we done? We changed the magnitude. Look at the magnitude you're at. You're at 24,000, almost 25,000. Okay. So your answer should be in the 24,000 magnitude. So otherwise you would have written 249, and 249 is greatly different than 24,900. Okay, do you want $24,900 or do you want $249? It's a big difference, right? All right. Key points to remember. 1, drop the numbers that need to be dropped if they're after the decimal point, like we did for number 3. Numbers before the decimal point, we replace with zeros like we just did with number 4. But 2 and 5 are before the decimal point. So they need to be dropped, but you cannot drop them completely. You just change them to 0 because your answer should only have 3 sig figs. And those zeros at the 24,900 are not significant, right? We only had 3 sig figs, 2, 4, 9. What if 29975? Okay. All right. Good question. Let's do that one. Let me get my text. The question is, what if the number is 24975? Right? Okay. Well, the number now is, what we're going to do here is to answer that question, because here's the thing with that. If we do this, then we got to change it to 25000. Everybody agree on that? Yes. Okay. But guess what? When we do that, we have only 2 sig figs. And so what we do is we have to put it in a different format. And it's called scientific notation, which is part of this chapter we're dealing here. We got to convert that number to scientific notation. And so that number would be 2.50 times 10. 1, 2, 3, 4 times 10 to the 4 power. Okay. This is foreign right now to you, but it won't here in a bit. And so when you get a number, which is a very good question, Claudia, is that you did it like you've been told, but then your answer ends up with only 2 sig figs, and you're supposed to put in 3 sig figs. Well, the only option you have is to convert it into scientific notation. Scientific notation is just another way to write very big numbers or very small numbers. Okay. And so that means that 2.54, which has, guess what? 3 sig figs, right? 2.50 has 3 sig figs. So in scientific notation, the first set number there always has the correct number of sig figs. Okay. If, for example, we wanted to write a number, the number 100 with 2 sig figs, it will be 1.0 times 10 to the 2nd power. Okay. And we'll get more detail about scientific notation. But only 2 sig figs. No, that 2.50, the way I wrote that, is the same rules applied. Look at that 0 in front of the 5. There's an integer in front of the 5, okay, and there's a decimal point. And that's why when you put it in scientific notation, that's always the correct number of sig figs. Okay. All right, and we'll have more. I don't want to jump early here, but it's a good question. We're going to get more into scientific notation because we will be writing, doing calculations with very large numbers, 6.02 times 10 to the 23rd. That's, take 6.02 and move that decimal point over 23 times. That's how big that number, one of the numbers, are going to be working with. That's Avogadro's number. If you were to count that number at a rate of 1 per second, 1, 2, 3, it'll take you a few thousand years to get to the end of that number. That's how big that is. All right. All right, good questions. Let's continue here. All right, so adding and subtracting. Now, what we've been doing right now has to do with multiplying and dividing with respect to getting the correct answer. So previously, we went through this exercise to determine how many sig figs they had here. Remember that, right? And then I went through, okay, if you multiply and divide the first 2 numbers, your answer should only have 2 sig figs, okay? And so that's what I went through, that little exercise. How many sig figs your final answer will have? And so then we started talking about rounding and did some examples, because now that number is the result of multiplying 2 numbers in which one of them or both of them had 3 sig figs. Okay. If both numbers have 3 sig figs, then your answer should have no more than 3 sig figs. But if one number had, greater than 3, but one number still had 3, then your answer cannot be more accurate than the one with the 3 sig figs. So that was the answer, 1.8374, whatever mathematical function you're doing. You determine where the 3 sig fig position was, and then you round it off, okay? This is what we did right now. Okay. Now, when it comes to adding and subtracting, okay, we're still dealing with accuracy, but we don't care about sig figs. What we care about is decimal places, okay? So your final answer, when you're multiplying and subtracting, that's important. Remember that. When you're adding or subtracting, adding or subtracting, adding, tomato, whichever, okay, your answer cannot have more decimal places than that number with the fewest decimal places. Because obviously, the one with the fewest decimal places is the least accurate, right? So we do a measurement here and we get 13.5478 feet. That's pretty accurate, right? Okay, because we're going to the fourth decimal place. So we got some instrument that's very accurate. But then we measure it with another instrument, maybe a ruler, okay? And our answer there is 11.20. We can only go to 2 decimal places, okay? So the one with the 11.20 is the least accurate measurement. And it only has 2 decimal places. So what we do is we do the math like we normally would do. You have all the digits there. Here you're subtracting it, but this is true even if you were adding it. Okay. And so here we get the answer of 2.3478, and you would be tempted to give that answer, but that would be incorrect with respect to accuracy. Okay. Because your least accurate measurement only had 2 decimal places, which means we go to the 4 and we round it on the 4. Round the 4. So we look at the neighbor is 7. That tells you that the 4 goes to 5. We drop the 7 and 8. Okay, why? Because it's after the decimal point. We don't put a 0 back in because we made it. We're back to 4 decimal places, which is not correct. And so your answer would be 2.35 feet. Okay. You might think, well, wait a minute. I got my first measurement. That's accurate to 4 decimal places. And that's true. No one's arguing that. But your second measurement is only accurate to 2 decimal places. Okay. So your answer cannot be more accurate than the least accurate measurement. In this case is the 11.20. That has nothing to do. No, you don't want to round it to the closest even number. Okay, let me see if I understand the question. The closest even number, explain that, the question. I don't understand the question. We round it just like we normally would, like the example. Okay, and
Yeah, I just remember there was something where it was even. We had to round to an even number, and I can't remember why, or when we did that.
The one we did here?
Yeah. I'll look back and see if I can find it.
Okay, you do that, because what you do like we do here, like we're doing the rounding, we're gonna cut it off at the second decimal place, right? And
Yes.
so we look at the neighbor, like we've been doing. The neighbor is 7. 7 is greater than 5. So
Right.
that 4 goes up to 5. But nothing about even or odd.
I wonder where I picked that up from, but thank you for
Okay.
saying
Yeah,
that.
no problem. Yeah. All right. Where are we at? Okay. Remember that's the 11.20 because that is the least accurate measure. Okay, now with respect to adding and subtracting, notice something here. If you focus on sig figs, okay, with respect to adding and subtracting, what's going to be the problem here? Let's take a look at the first. How many sig figs here? Somebody tell me how many sig figs in 13.5478? Exactly, 6 sig figs. How many sig figs in 11.20? 4. That's correct. I don't know, not 3, but 4. Remember that 0 is in front of a integer, and there's a decimal point in 11.20. So there's 4 sig figs. and look at the answer. How many sig figs in the final answer? So we got 6 sig figs here. We got 4 sig figs here, but our final answer has 3 sig figs. Okay. And so sig figs, when it comes to adding and subtracting, and that's important, adding and subtracting, sig figs do not play a factor here. Okay. Decimal places, focus on decimal places. Okay. Yeah, no problem. All right. Adding and subtracting is, this is just a reminder as to decimal places and what the magnitude and where you're at, just to help you remember, you know, your magnitude, you know, you're in the hundreds, tens, 1,000, so on and so forth. All right. Now, when it comes to multiplication and division, okay, you focus on significant figures. Do not focus on decimal places, apples and oranges here, right? All right. And so how many sig figs do we have here? 3.546. We got 4 exactly, 4 sig figs. And how many at 1.4? We got 2 there, 2 sig figs. So our answer should be no more than 2 sig figs long, because the 1.4 is the least accurate measurement. And so when we do the math, we end up with a number of 4.9644. Let me clear my mess there. Okay. And this had 2 sig figs, so our answer has to go, we go to the 2 sig fig position, which is right there, the 9. That is our 2 sig fig position. We look at the neighbor, okay, the neighbor is 6, which is greater than 5. Therefore, the 9 gets bumped up to 10, which we got to carry the 1 over. So our answer with respect to significant figures is 5.0. And guess what? Where did this come from? It's our area calculation here. Well, our units, we got meters. Don't forget meters times meters. You know, this is a 1 there. So we can simply add the exponents. And if we were doing one more, so if it was meters times meters times meters, guess what my units would be? Meters cubed, exactly. And that would be volume. Okay. Somebody's speaker keeps popping in and getting some reverb. All right. So don't forget your units, even though you're doing the mathematics, the units come along with it. Okay. All right. So multiplying and dividing, focus on sig figs. Adding, subtracting, focus on decimal places. Don't mix and match. Okay. Don't mix and match. Which brings us to scientific notation. In the earlier question we had when we were trying to write a number and go to 2 decimal places, and we ended up with what, 25,000, but the question asked us to put us in 3 sig figs. Well, whenever you have a doubt about the how to write the sig figs with the correct number of digits, convert it to scientific notation. Now, scientific notation, as I stated, is a convenient way for you to write very large numbers or very small numbers. Okay. Most calculators, if we were to manually put a number as big as the one I mentioned, it'd be very difficult. It won't accept it, but it will accept scientific notation. Now, don't let the scientific notation scare you mathematically. It's simply just a different way, a shorthand way to write a large number so you can input it into your calculator. Once you input in your calculator, the mathematics is the same. It's a number. You can add it, subtract it, get the square root of it, do whatever you want to do to it. It's just you have to put it into a notation so your calculator can understand it. Okay. So very large numbers or very small numbers. Okay, now let's take, for example, how do we do that? Now, the distance from the Earth to the sun is approximately given here, 93 million miles. Okay, so what we do to put in this big giant number into scientific notation, we know the decimal point is going to be, let me change the color here so I'll get a contrast. We know that the decimal point's right there, right? Anybody disagree on that? That's where the decimal point would be, though it's not given, right? So what we do is count the decimal places and we continue moving from right to left until we find the last integer, the last whole number. Okay. But before we do that, we have to determine how many sig figs does $93 million have. It's $1 million. I got dollars in the brain. 93 million miles. How many sig figs does 93 million miles have? 2 exactly, because you got to write it in with 2 sig figs at the end. So my 2 sig fig position will be right here. All right. So starting from the far right, we're talking about numbers that are greater than 1. All right, so we go and we count. We go 1, 2, 3, 4, 5, 6, and 7. Okay, that's where we get the 7. So it's 9.3. And then we put the times 10 to the 7th power. Okay. What that means, this is just no different than saying 9 times 3 times 10 times 10 times 10 times 10 times 10. I got 7 here. 1, 2, 3, 4, 5. Do I have 10, 7 tens? Yeah, 1, 2, 3, 4, 5, 6, 7. That's what that means. And if I just combine all those tens, just like we did earlier, we said m times m. It's understood to be a 1 up there, and that is equal m to the square power. Well, 10 to the 1 power is what we're saying here. 10 to the 1 power. Add those up, you get 10 to the 7th. Okay, and so you take 9.3, multiply it by 10 7 times, you get $93 million or miles. Okay. So instead of writing it, 10 times 10, 10 times 10 times 10, you just go 10 to the 7th power. Now, in scientific notation, the format is an integer, which I'm going to denote by the letter, let's just say A, and then the decimal point, and if there's a number that follows, I'm going to denote by the letter B, C, D, etc., times 10 to the X power. But the format is this. All right, there's the integer first, the decimal. If you got more than one sig fig, you got the decimal point. That's where it goes, right there. Okay. Writing it 93 times 10 to the 6, though it does represent 93 million miles, is not the correct format for scientific notation. There's always going to be an integer followed by the decimal point if needed. If there's no numbers after the integer, you just leave it blank. just that number, whatever that number would be. Okay. Now I state that because sometimes calculators will give you the answer after a mathematical function with like that, 93. So you got to convert that, move the decimal point over to the left by 1, and that makes it 9.3 times 10 to the 7th power. Okay. And I'm going to go over your calculator because there's 3 buttons, 3 different methods of inputting scientific notation in your calculator. All right, now for writing small numbers, notice the number we just did was a number greater than 1. We ended up with a positive exponent, 10 to the positive 7. All right, here we find the decimal point, which obviously we recognize that this number is much smaller than 1. So that tells you that my exponent is going to be a negative value. So I find the decimal point, which is right here, and I simply go to the right. Notice the first number greater than 1, I went from the right to left. Here I'm going from left to right. And I continue until I find the first whole number, integer, and I move the decimal point right after that. First one I find. Notice the first one would be a 1. So I got to count the number of decimal places to here between. Note I have 2 sig figs. Everybody agree that this number has 2 sig figs? Therefore, my answer in scientific notation has to have 2 sig figs. And so I count from here. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So I got to go 10 decimal places to the right. So my answer is 1.7 times 10 to the negative 10. Okay. You know what this means is it looks complicated, but it really isn't. If I break it down, negative 10 tells me that I'm taking 1.7 and I am taking 10 times 10 times 10, 1, 2, 3, 4 times 10, 10 of them, etc. Get 10 of those 10s underneath. I'm taking 1.7 and I'm dividing by 10 and times 10 times 10 times 10. Okay. And so my number, negative 10, tells me it's a digit, very small number. It's a number less than 1. Obviously here in scientific notation, 2 decimal places. If, for example, there were a 0 here, if there were, then I would simply put another 0 right there. Okay. So I can present that value in the correct number of sig figs, which would be 3 if there was a 0 after the 7. Okay. All right. Now, convert to scientific notation here. We first take a look at the number. Well, step number 1. Always when you convert a number given, determine how many sig figs you have. So the first number, 548.005, how many sig figs do we have? Exactly, 6. So I combined sig figs and 6. So we have 6 significant figures, and therefore our answer should have 6 significant figures, sig figs, okay? Next thing we do, you find the decimal point, which is right there. Obviously, this is a number greater than 1, so I'm going to end up with positive exponents. I go 1 and 2, and so that becomes 5.48005 times 10 to the 2nd power. Exactly, Skylar, you got it. You got to maintain the number of sig figs. Over here, you have 3 sig figs. Number 2. So you come across, you go starting from over here, you go 1, 2, 3, 4, 5, 6, and 7. You got to stop at at the stop before the last integer. We have 3 sig figs, so we got 6.81 times 10 to the 7th power. Okay. Over here, we have 3 sig figs for number 3. This is the number less than 1. Guess what? I'm going to have a negative integer. Here's my decimal point. I go 1, 2, 3, 4. I stop it right after the first integer. And so I got 4.00 times 10 to the negative 4. Okay. And then finally, the last one, I only have 1 sig fig. Okay. And so here's my decimal point. 1, 2, and 3. So 2 times 10 to the 3rd power. Okay. Let me clear my mess. And we'll show it that way. Okay. See how that works? Now, if, for example, the question was asked, write the number 2000, write it with 2 sig figs. Well, obviously we couldn't write it just by saying 2000, right? Because those zeros are not significant. So when that occurs, then we simply convert that 2000 into scientific notation, and that is how we write 2000 with 2 sig figs. If you're asked write 2000 with 5 sig figs, guess what? 2.0, 1, 2, 3, 5 times 10 to the 3rd. That is the number 2000 with 5 significant figures. Okay. So scientific notation will always be the first digits are always in the sig figs, and the correct number is sig figs. All right, now there are 3 buttons in your calculator depending on the type of calculator that you have. Now there are the older calculators have a button that is labeled double E, capital EE, and some calculators, for example, my Windows, my computer calculator has a button labeled EXP. Now the newer calculators have a button, and see if you look at that one, let me point it out. The arrow here. So if you look at that one there, that button there, it circled the buttons. Okay. The one in the white, that is from the Windows calculator, or some calculators, handheld calculators, have an EXP button. That's called the exponent button. Or they may have the double E button that's up here in the top right corner image. And then the newer ones have a button labeled X times 10 to the X. Okay. There's X times 10 to the X. Don't confuse that with a button, okay, that may be labeled as 10 to the X. That is not the same button that you need to do. And some people may want to type their number in, like 2.45, hit the times table, and then hit the 10 to the X button. That is not scientific notation, okay? That's totally different mathematical function. So look for a button that has an X and then times 10 to the X. Now, they could be the primary button, and sometimes they are the secondary function. So you look around, and you might want to refer to your manual as to which is your scientific notation button. So it could be the primary button or a secondary button, which means you got to hit the secondary button to access your scientific notation button. So let's say, let me clear that. So those are the numbers that you would get. For example, if you were needed to type in this number 2.39 times 10 to the 9th power, you would type in 2.39 as you normally would, okay? Then you hit the function button for scientific notation, whatever button you have on your calculator. Then at that point, the only thing you're inputting into your calculator is the exponent, okay? Now, the other button that you should be aware of is the negative positive button. It's a toggle button. Now, some of them have a positive button, some have a negative. Now, for example, the calculator image that I show, and I circled right here, this one right there. Where's the other one? Oh, this one right here. And I can't see it very well in the image that I have in the far left corner, but there should be a toggle button that says positive or negative, where you can input a negative value or a positive value, okay? And sometimes you're going to need that if you're going to put in a negative exponent. So going back to how we're putting this number in, 2.39, you would type in 2.39, then hit the function button, whichever function button you have, and then input the exponent value. That's all you do. Now, if it's a negative, then at that point, you hit your negative positive toggle button to get that exponent into a negative value. Okay, so determine the button for your scientific notation, and then determine the button for your negative positive toggle button. Okay. For example, let's do, let me see, let me share my calculator, and this is the oh, maybe not. There it is. Okay, this is the Windows calculator, and so if you go to the menu, you can click the scientific selection. I had it on standard calculator, and there's the exponent, EXP, that is my scientific notation. So if we're going to type in a 2.39 times 10 to the 9th, I would type in 2.39. Then I hit the EXP button. Notice what changes up there. You get an E plus 0. Then at that point, I would input the 9. Okay, the plus tells me that 2.39 E times 10 to the 9th power. That E replaces the times 10 to whatever exponent for the calculator. Okay, now if that was a negative 9, then my toggle button here would be changing that. You know, plus negative. See how that works? Okay. That toggle button too could be, what if this was negative 2.39 times 10 to the negative 9? Well, no problem. What I do is I type in the 2.39 first. Oh, okay. Then make it a negative. Notice I made it a negative. Okay. Then type in the EXP button or the double E button or the other button on the other calculator. Then type in the 9, the exponent, and even make that negative. So in this case, I've inputted negative 2.39 times 10 to the negative 9. Again, it's just another way to convert this into scientific notation. I have another button here. In this case, it's an FE, or it could be an engineer ENG button, but that puts it, that can put your number back into long form. Okay, there's that number I just inputted. Long form, there's that number. I can put it back in scientific notation format for the calculator. Okay. Now, if I wanted, if that was my answer that you see my calculator there, obviously that is not the correct format for scientific notation. I would need to convert that and say, oh, let me change the color here. I need to convert that and say negative 2.39 times 10 to the negative 9. This would be the correct format. This is the format for scientific notation of the calculator, okay? Of the calculator. Some of the fancy calculators will actually put it in the correct format. It depends how fancy the calculator you have, All right, once I put that number in, now you can do the mathematics, whatever you want to do. I multiply this number, maybe I want to divide it by whatever, do the mathematics, or you do whatever you do mathematically, do it, okay? Multiply, divide, add, subtract, so forth. So be familiar with the calculator because you will need it. If you have trouble finding out what it is, take a picture of it, if you will, of your calculator, close up of your calculator, send it to me, and I'll see if we can determine where's the button, which button you need to push, okay? Okay, here's the same picture of those three calculators all separated. Like I said, the newest calculators have, on the far left, have the X times 10 to the X button. And the older models have a double E button. And then some have the EXP button, so. Find that and also find the negative toggle the button for the negative value. You toggle it back and forth, positive, negative. All right. So you're going to need a calculator, obviously, because you might have to do something like this mathematically. So try this on your calculator. Okay. 2.84 times 10 to the 23rd. Divide that by 7.24 times 10 to the 12. Okay. Take a few minutes. Why don't we take a break? Try that on your calculator while we take a 15-minute break, and then we'll head back. I got 219. Let's come back at what, 235? All right, 235 it is. So I'll come back, finish this slide here. We'll go through that example, and then we're going to jump into the next chapter and actually doing some calculations. All right, back in. Okay, let us continue and finish up what we got going here. I jumped a little bit ahead of myself. Let me go back. Where was it? Right there. Okay, so the problem is here. Try this at home on your calculator. You're taking 2.84 times 10 to the 23rd. Okay, your calculator gave you 3.92. Okay, well, I'll run through it myself and we'll see what we come up with. Okay. Now, two things to remember. We're looking at these. Now, how many sig figs does 2.84 times 10 to the 23rd have? Okay, how many sig figs in the numerator? Oh, not 33. 3. You are correct. And how about 7.24 times 10 to the 12? Obviously 3. So therefore, our answer, because we're doing a division, our answer should end up with 3 sig figs. Okay, so let me pull up my calculator, and I'm going to share my calculator, and you got 3.92 times 10 to the 10th. Okay, let's see if you verify that. All right, clear it out. I'm going to take 2.84. I'm going to input my numerator. So I type in 2.84 like I normally would. Then I type in my scientific notation button, whatever that button that is, EXP for this one. It is 23, the exponent, positive 23. So for Windows, it's shown as 2.84E, which means the exponent, times 10 to the 23rd. We're going to take that and divide that by 7.24. So I hit the divide button like I normally would to divide any number. 7.24 exponent to the 12. Okay. And I plug it in. I get this big old number. Okay. Now I'm going to take this number It's not allowing me. What's going on here? Okay. So obviously we wouldn't report that number in that format because there's way too many digits. We just determined that we got 3 sig figs on the numerator, 3 sig figs in the denominator. So our answer should have no more than 3 sig figs, but I'm going to go ahead and put in that whole number that was given as so. Okay. And in reality, what we're doing, remember, that's not the format for scientific notation. So what I really want to do is take times 10, and I use that button to tell me exponent, okay? And it's a positive 10. So that is the number that the calculator gave to me. All right. We recognize that we only have 3 sig figs, so we go to the 3 sig fig position, starting to the far left, and it's that number right there, the first 2. Okay. We look at the neighbor, which is a value of 2, which tells you that the first 2, the 3 sig fig 2 position will remain a 2. Okay. So therefore, our answer would be 3.92 times 10 to the 10th power. And I think I got it right there. Okay. Now, like I stated, please don't type in that number that calculator gave you. It's not, you're not that accurate. Okay. Because you did not have numbers that were accurate. You have two sig figs on top, 3 sig figs on both cases. All right. So anyway, let's clear this up a little bit so you can see what it says here. This is mentioning about your calculator. Sometimes it gives the number, the exponent as a little superscript. That is not the scientific notation format. It's just telling you that 1.2, 3, 4, 5, 8, etc. It is times 10 to the 8th power. Okay. All right. All right. If you need help with the calculator, shoot me an email of an image of your calculator so we can search for your buttons, or look at a manual that came with it under scientific notation, and practice a couple of things. Practice a few prompts so you're familiar with how to input that number, and then also practice how to put that answer into correct sig fig and scientific notation format. Okay. All right. So last item here, we're going to talk about percent. You're familiar with this already. Okay. Obviously, our exams, we do. We have a 100-point question. You do 80 questions out of 100. Obviously, 80 divided by 100 times 100 gives you the percentage of your grade, right? Well, that's what percent is. You got the part over whole. 100-point question, 100 is the whole. The part is 80 for what you got, times 100, and it gives you the percentage. So, and that's true for, most anything you want to try to calculate a percentage of. And so a gold ring here had a mass of 239.45 grams. They did analysis. It had 198.3 grams of pure gold. What percent of gold is that? Well, we set it up. We get 198.38 divided by 239.45, because 239.45 is the whole. That is the total weight of that ring. And 198.38 is the how much gold was found in that whole ring. You take it, divide it, multiply 100, you get this big old giant number. Okay. Obviously, you want to give the right sig figs. Both digits, numerator, denominator, both have 5 significant figures. So you need to truncate at the 5 sig fig position, which is the 848, the last 8 there. And you look at the neighbor's a 1, so 8 remains 1. And the answer is 82.848% gold. Okay. All right. So take a look at the chapter. You have some worksheets in your module. Yeah, start practicing, working them through. In mathematics, the more practice you do, the better off you are. Really, practice. So do as many of those problems as you can. If you have any questions, shoot me an email. I definitely will get back to you as soon as I can with an answer. Okay, so okay. Congratulations, we're done with chapter 2. Any questions about chapter 2 before we kick into the next chapter? Any questions? All right. Well, we're going to be doing some metric factors here using the metric units. Now, I sent all of you an email which had this. It was a Word document, could have been a PDF, but it had this table which dealt with metric units. A lot of people have trouble with metric units, and that's okay. The U.S., we've been trying to convert ourselves to the metric units since I was in school, so that's like 100 years ago. And it's interesting that now it's gone to the point where you can go to the grocery store and get a gallon of milk, but you need to purchase a 2-liter bottle of soda pop. So we've interchanged the units. All right, well, what I've done here, I put a table, mass, volume, and length. Mass, generally we're dealing with the unit, standard unit being grams, volume liters as the letter capital L for liters, and the length is meters, okay? Now we have what we call deciliters, centiliters, milliliters, and microliters. Now you can interchange these prefixes, whether it's a mass or whether it's a volume or whether it's length. That's a neat thing about the metric system. We're increments of the factors of n, if you will. For example, in the far left, we know that in 1 kilogram, there are 1,000 grams. For volume, in 1 kiloliter, there's, guess what? 1,000 liters. And guess what? In 1,000 kilometers or kilometers, there are 1,000 meters. That's the first entry. Now, you might ask yourself the question, how many years in the decade? Well, guess what? If you don't know, it's 10. There's 10 years in the decade. That's the prefix for decigram. There are 10 decigrams, E, notice the D there, in 1 gram. As there are 10 deciliters in 1 liter, as there are 10 decimeters in 1 meter. Okay, so if I had a meter stick, which so big, I will have 10 units of decimeters. Okay. Now, how many years in a century? 100, right? So guess what? In 1 gram, there are 100 centigrams. And in 1 liter, there's 100 centiliters. And in 1 meter, there are 100 centimeters. Okay. And how many years in the millennium? If you don't know, there are 1,000. There's 1,000 years in the millennium. And so in 1 gram, you have 1,000 milligrams. And in 1 liter, you have, guess what? 1,000 milliliters. And guess what you have in 1 meter? You have 1,000 millimeters. Okay. Now, the unit you may not be familiar with is called micro, and it has a symbol. It looks like a U with a little tail up front. Okay, a little Greek symbol there, micro. There are 1 million micrograms in 1 gram, as there are 1 million microliters in 1 liter, and there are 1 million micrometers in 1 meter. And so in a meter stick, for example, if I were to make those units of microliters, I would have 1 million little lines all across that 1 meter. Or for millimeter, I'll have 1,000 lines or markings on that meter stick, or 100 centimeter markings in 1 meter, or only 10 markings for the decimeter. Okay. You see how that works? And I can interchange. Now, every one of these conversion factors I just gave you here is a ratio, which I can write given here. I can write, for example, I know there's 1,000 grams in the kilogram. I can write that with either kilograms in the numerator or kilograms in the denominator. Okay. And how which one I select depends on the question asked and keeping track of my units so I can follow my units through to cancel out. For example, if I was asked a question, how many micrograms are in 0.125 grams, I could set it up as follows. I first write down what I'm given, which is 0.125 kilograms, and I look for a factor that I can get rid of kilograms. Well, I know from my table up there that there are 1,000 grams in the kilogram. So I can set up this factor in this manner, and I write it with kilograms in the denominator. Why? Because when I multiply 0.125 kilograms with the first factor, guess what? My kilograms cancel. Okay. Some people have a challenge with this, but I refer you to your algebra. For example, if I have the units a squared divided by a, what that really says is I got a times a. Remember I was showing you how the exponent just, it's a 1 here, a to the 1 power, a to the 1 power. Well, it's really, I can write 8 times a divided by a. And I know these are common units. I can cancel one set of a, right? Guess what? Kilogram times kilogram. My kilograms cancel. Sometimes if you don't see that number as a ratio, that first number, well, just put a line under there. Any number you can make a ratio by putting that line and put a 1 underneath. That's a ratio. Okay. You can see how kilogram units cancel. And so at this time, that first factor, once I finish with the math, I'm in units of grams. Okay. But am I at units that I'm looking for? No, because what I'm looking for, given the problem, you always keep track of where you're trying to get. This is where I start. This is where I got to get to, micrograms. So I need one more factor that gets rid of grams, but puts me in microgram units. And I know that in 1 gram, there are 1,000,000 micrograms. So I set that up with micrograms in the numerator, grams in the denominator. My grams cancel out. Guess what? Unit-wise, what I'm left with after the math is done is micrograms. And that's what I mean. 99%, you set it up in this manner by keeping track of your units. You set the problem up correctly. Now the math is on you because you have control of your calculator to punch these numbers in, get the right answer. Okay. Notice something here. All these factors are exact numbers, so they wouldn't be a factor with respect to sig figs. The number given here is a measurement. So you got 3 sig figs on that there. So your answer should have 3 sig figs. It's written here in long form. That's fine. You can give the answer in long form, or if you're more comfortable, convert it to scientific notation. Okay. So do study the this table I gave you because it definitely will help you out with respect to uh, these conversion factors. Now, you have these three conversion factors that convert from English to metric, and you can write them, set them up either with inches in the numerator or inches in the denominator. Okay, the same is true for the other factors. And this is true for any ratio. We're going to be working with a lot of ratios here. Okay. The units, for example, of the periodic table, those atomic weights, those have units. We haven't talked about those, but those have units. Those have units of moles per gram. I understand we don't know what moles are, but we will. Okay. And that therefore was that what that tells you is that atomic weight of the periodic table, those could be written with either moles in the numerator or moles in the denominator. You know, anything 50 miles per hour, I can write it one or two ways, 100 miles per hour, whatever the case may be. Okay. Now, why would I want to do that? Okay. What I'm going to do now is I'm going to give you a very extreme example of unrelated things. It's a crazy example, but I do that for a reason to demonstrate to you that you can convert anything to anything if you have conversion factors. I used to use this example for my dental hygiene students because we were having some challenges setting problems up. So I set this up using some units that are just wacky units, but there's a point why we have it set up like that. Let's make sure I set up the right, share with you the right one. Okay. Some books call this dimensional analysis, okay? Or the factor analysis, there are all kinds of names for it. They simply keep track of your units. That's all it amounts to, okay? Now, if I have conversion factors, like I stated, I can get from point A to point B, okay? So I have a problem here. It says, given the following conversion factors, how many DH, which was dental hygiene students, equals 4.5 bananas? Okay, you might be thinking, Dr. Fred, you're going off the deep end. Okay, well, maybe I am. But I have conversion factors. I have a conversion factor. I can tell you that 1 DH is equal to 6 grapes. And guess what? I got 3.5 grapes that are equal to 1 orange. Excuse the plural. I didn't set that up properly. And then I also have 1 orange is equal to 6 toothbrushes. And guess what? I got 3 toothbrushes equal to 1 banana. And you're like, okay, how does that help me solve the problem? Well, let's set it up then. Okay. So first one, we are given 4.5 bananas, right? 4.5 bananas. And I should write here because the ultimate goal is to write down where I need to go. And I'm way down here. I need to figure out how many DH students at the end of my conversion factor, unit-wise. I'm given 4.5 bananas, all right? So here's my factors here, conversion factors. So I gotta look for a factor that has bananas in there that I can get rid of bananas, and sure enough, there's one. I got that 3 toothbrushes is equal to 1 banana. So I set it up with bananas in the denominator, excuse me. Why? Because when I do the math, be it A divided by A or bananas divided by bananas, it's a unit. They get canceled out, okay? So at this point, I've converted the 4.5 bananas to toothbrushes. But is it where I need to be? I need to be down here, dental hygiene students. No, it's not. So I need another conversion factor, okay? And my next conversion factor is something that relates toothbrushes to something else. And what I have is that I got 1 orange is equal to 6 toothbrushes, okay? Kind of crazy, huh? It's okay. Keeping track of my units. Okay, I haven't done anything with the math yet. I'm just keeping track of my units. And guess what? My toothbrushes cancel. I'm left with units of orange. And if the question asks for oranges, I could stop it right there because I'm with respect to units of oranges, and that's where I need to be. Now the math, I just simply do the math, but I'm not where I want to be. I need to get to DH, okay? So therefore, I got to find another conversion factor that gets rid of my oranges, and there's one that's 3.5 grapes to 1 orange, okay? And so as I progress and I set up my system, I am canceling out my units. Now, this is typical for some of the chemical problems that we're going to be doing. 3 conversion factors. That's the typical type of units, a number of units that are conversion factors to get from point A to point B that we will find in the chemical problems that we're going to be doing. Okay. Well, we're going to take a few more here. So I gotta get rid of grapes because I'm at the grape stage and I need to get the DH. So I got one more unit, and guess what? Now, with respect to units, I'm there. My bananas cancel, toothbrushes cancel, oranges cancel, grapes cancel. With respect to units, I'm at DH student units, which is where I'm trying to be based on the question that I've been asked. Okay. We never want to lose track of where we started and where we need to be, because that helps us set us up with the next conversion factor. Okay. Now I'm there unit wise. I've set that up properly. Okay. Now some may be tempted to convert that 3, invert it. So no, just either keep the numbers as they are, just invert the units as needed. Okay. It could be 3 toothbrushes over 1 banana, or the other way around, 1 banana over 3 toothbrushes. Don't change the factor, the unit. Just leave those numbers as is and just put them where they need to be. Now the math is on you. Okay. Plug it through. And guess what? 4.5 bananas is equivalent to 1.3 DH students. Okay. So crazy example, but it's trying to make a point, because a lot of these problems are going to be as foreign as this particular example here. And I'm trying to demonstrate that given conversion factors, which you will always have access to, okay, you always have those, you can set up these problems properly, follow your units, make sure the units are canceling out properly, and then you're good to go. Okay. And it's a matter now of plugging the numbers in and doing the mathematics behind it. All right. So I also sent this PowerPoint slide out to you. So if you haven't had a chance to look at it, do take a look at it. Okay. All right, because we're going to be using similar technique when we're doing this, what chapter 3 is all about, is doing conversion factors. All right. Now, I did mention already the units, what we use in the metric system. We got the symbol lowercase m for meter, lowercase g for grams, uppercase L for liter, and time via English or metric, everybody uses second. Okay. Now, I gave you a table with respect to the prefixes of deci, centi, milli, and micro. Okay, so this table kind of describes it a little bit further for you. There's the respective symbol, the prefix symbol, utilized for those units. Okay, and each prefix represents a power of 10. So we know that in 1 meter, if you look at the prefix centimeter, remember, to help you, there's 100 years in a century, right? So you can go very quickly and say, oh, all right, oh, I went too far. There's 100 centimeters in 1 meter. In 1 meter, there are 10 decimeters, okay? Because there are 10 years in a decade to help you out. 1 kilogram, there's 1,000 meters, okay? And there is 1,000,000 microliters in a meter and 1,000 millimeters in 1 meter. Okay, there's 1,000 years in a millennium to help you out. All right. So Now, dimensional analysis or factor label method. All right, same thing. Basically, keep track of your units and figure out the problem. Okay. Identify, the method is this. Identify units for what you want to find, what you're looking for. What is the answer? What is the question asking? Okay. Identify what is given to you in the problem. Okay, that's your starting point. Okay, then you start identifying conversion factors to get you from where you're at and where you're given to what you're looking for with respect to units. Okay? And you set those up properly and keeping track of the correct units and making sure things cancel out. And then it's a matter of doing the mathematics. Okay? Show your work if you're asked to show your work, and what we mean by showing your work, and that is to show your conversion factors. Now, I realize that some of you may be familiar with the ratio method of finding these factors, and I don't recommend using that unless you're like 100 super duper % correct and understand it, because what has happened in the past is once, if you don't set that ratio system up properly, you will go out in left field someplace. Okay, you're better off to follow this factor label method, dimensional analysis method, because you can see the units if you set those up and you follow the units as you set your problem up. All right, so for example, you'll be asked, how many liters are there? 2,389 milliliters. Well, we write down what we are given, and we know that we have a conversion factor. You know, I should also make note for myself, but prior to that, I should have written here what I'm looking for. Okay, I write down what I'm given, so I should really be up in that position. Write down what I'm given, write down the units that I'm looking for. And then I start putting in my conversion factors, because I know that in 1 liter, there are 1,000 milliliters. And notice that my milliliters are canceling out, leaving me with units. Okay, I have 4 sig figs in what I'm given, so my answer should have 4 sig figs. Okay, how many kilometers are in 12,300 centimeters? Okay. So I write down what I'm given, and eventually I need to get to kilometers. And I write that down because I just want to keep track of where I'm at, where I need to go to. Okay, that's my map. And I need to know where I start. I need to know where I end up. So I have 2 factors here. Now, my first factor, I know that in 1 meter, there's 100 centimeters. And I do that because that gets rid of my centimeters. Now, I'm not in the kilometers units, so I need one more factor that converts my meters into kilometers. Now, you might notice that if you can combine these 2 into 1 factor, and if you recognize that, then go ahead. There's not a problem in doing that. A lot of these factors you can convert into 1 factor. You recognize that, then go ahead, just show me how you did that. But if you're not familiar with that yet, stick with what, start slow, start putting units in so you can cancel things out slowly, and then until such point that you can recognize, hey, I can combine those 2 calendars and 2 factors there and give me kilometers per centimeters. Okay, because notice my meters cancel out. I can make 1 unit. And then that's true, you can do that. But I didn't want to confuse it yet. Keep it separately until you're comfortable with combining things. All right, so with that being said, units cancel out. I have 0.123 kilometers are in 12,300 centimeters. Again, you can follow your sig figs through. Okay, 3 sig figs. All right, let me do this. Now, there's units in English units that if you're not familiar, you may want to be familiar with. 2 cups in a pint, 2 pints in a quart, 4 quarts in a gallon. Obviously, there's 12 inches in a foot, 3 foot in a yard, 1760 yards in a mile, 5,280 feet in a mile, 60 seconds in a minute, etc., etc. Okay. This little aid helps you out. We got the big G on the outside. That represents a gallon. There are 4 Q's inside the big G, represents 4 quarts to the gallon. Okay. And then there are 2 pints. So let me write it this way. 1 gallon is equal to 4 quarts. Okay. And then 1 quart, there are 2 pints. There's 2 P's inside 1 quart. And within 1 pint, there are 2 cc's, which represent cups. Okay, so those are my conversion factors that may help you to remember going from cups to gallons. Okay. Each one of those, again, are a conversion factor. For example, how many gallons are in 44.5 cups? And so we write down how many cups we have. Okay. Eventually, I'm going to be over here that I need something in gallons. That's what I'm looking for. So I know that in 1 pint, there are 2 cups. So that gets rid of my cups and gives me pints. Then I know that there are 2 pints in a quart. That gets rid of my pints and gives me quarts at this point right here. And then finally, I have my last conversion factor where I'm in the gallons. So notice that quarts cancel out, pints cancel out, cups cancel out. So unit-wise, I am at the units that I'm looking at. Okay. Can anybody tell me, just looking at those conversion factors, how many cups in a gallon? $16, exactly. See, notice what I did here, is to hopefully you can recognize that I can combine these 3 conversion factors, and I end up with 1 gallon is equal to 16 cups. Yeah, because I multiply 4 times 2 is 8 times 2 is 16. My pints cancel, quarts cancel, leaving me with gallons over cups. Okay. Now, if you don't see that, that's okay. Keep them separate. Keep them separate, but you can combine them. Or you can even combine these gallons into pints, or vice versa, quarts into cups. Okay, any combination thereof. Okay. All right. Made a mess here. Let me clear this up. Then here we have how many inches in 3.5 yards. Okay. Well, we write down, sorry, finish it up at 2.78 gallons in 44.5 cups. Right now we're working with staying within units here. We're in the English units. We just did a stay in the metric units. Eventually we're going to convert from English to metric, metric to English. Here we're asked how many inches are in 3.5 yards. Well, we're given that there's 3.5 yards. What we're looking for is units of inches. So we're over here, 1 inches. Okay. And so I write that down to keep track of where I need to go. So my first one, I want to get rid of yards. And I know that there are 3 feet in the yard. So that gets rid of yards. But I'm not in inches, but I got to go 1 more factor. And I know that in 1 foot, there are 12 inches. Okay. and keeping track of my factors here. Yards cancel, feet cancel. Guess what? I'm in units of inches, which is what the problem asked for. Now I can simply just plug in the numbers and get my answer. Okay. Now, can I present that answer like that? Let me clear this up a little bit. Can I present my answer as 126 inches? That is correct, because we're dealing with sig figs. My conversion factors are all exact numbers. And my 3.5 is a measurement, which has 3 sig figs, right? Excuse me, 2 sig figs. My answer written in 126 has 3 sig figs. So I need to change that. So I need to change at the 2 sig fig position. So like we did before, I find the 2 sig fig position, that's a 2. I look at the neighbor's a 6. So what does that tell you? That tells me that the 2 gets up to 3. We don't drop the 6. Remember, it's before the decimal point, so we add a 0. Right? If we drop the 6, we end up with 12, which is the magnitude we're at is 100. We're in the 100 magnitude. Okay, so our answer is 130 inches. And that would be correct with the accuracy of our measurement. Okay, good. All right, so these are the units I talked about earlier that are found in your shape table. 1
Professor,
inch. Yes, go ahead.
I have a question. Why 130?
Okay, 130 because how many significant figures in 126?
3.
3. Okay. The first two, the conversion factors are exact numbers, right?
Correct.
So we can't use those to determine sig figs. But how many sig figs? 3.5.
2.
2. So our answer should have no more sig figs than our least accurate number, which is 3.5, which is 2 sig figs. How many sig figs in 126?
3.
And how many in 3.2? 3.5?
2.
Okay. Look at our answer. How many in 130? How many sig figs?
Will be 2.
Yeah. Is that follow the rules of sig figs?
Yes, however, why not only 13 inches? Why 130 inches?
Okay. Look at the magnitude number. Why? What you're asking is this? Why not 13? Right?
Yes.
Okay. Let me ask you a question. What if I put? Let me clear this out. What if I put a dollar symbol? How much money do I have?
$126.
Okay, so I'm going to round it up. If I were to do what you just told me, how much money would you get?
113.
Okay, so which would you rather have?
130.
Yes, because by dropping that 0, you lost the magnitude. You're in the magnitude of hundreds here. You don't want to lose. You don't want to lose the magnitude that you're in.
That I understood, but I thought the magnitude will be the 3.5 yards since that's the question.
No, the magnitude of answer. Okay.
Oh, okay. Understood.
Of your answer, you're in 100 magnitude.
Okay.
Okay, and so you wouldn't want to change. You're in 100, and by what you want to do, you go in the tens. Okay, over here you're in the hundreds.
Okay.
And by dropping a 0, you lost the magnitude to where you really are at. Don't confuse that with over here. here for yards, you're in the three magnitude for yards. But in the inches, you're in the 100 magnitude.
Okay,
Okay,
thank you.
sure. All right, we're okay. So these again, exact is the first one. So the 2.54 would not be used as sig figs, but the other two, the 454 and the 946, could be a factor. Okay, could be a factor. Here, we're basically just giving more problems. We're giving how many pounds are in 248 grams, 248. Well, we know that the 248 grams is given. Our conversion factor based on the table. Do use our conversion factors, okay? Because yes, I understand you can get other numbers, but Canvas, the answers in Canvas are related to the conversion factors that we utilize with respect to sig figs. Okay. Yes, there are numbers 254 point to infinity as far as conversion factors. Try not to use those. Use the ones we have. So 248 grams, we know based on the conversion factor, 1 pound is equal to 454 grams. We write it so that grams is in the denominator, so grams cancel, leaving us with units of pounds. And now it's a matter of you plugging in the numbers and keeping note that 248 has 3 sig figs, 454 has 3 sig figs. So our answer should have no more than 3 sig figs. Okay. How many inches in 3.54 times 10 to the negative 23rd, excuse me, negative 3 kilometers. And so I added some additional factors here because to show you how it was done. Some of these, obviously, you can combine, okay? But until you're comfortable with it, I strongly recommend using all the factors until you're comfortable with setting these problems up. Keep it in mind, you see 3 conversion factors. This is typical of the type of chemical reactions calculations that we will eventually be doing, okay, using this system here. And so from respect to units, I'm given 3.54 times 10 to the negative 3rd kilograms, okay? I know that there's 1,000 meters in 1 kilogram, so I set it up with kilometers in the denominator because they cancel out. So that leaves me the units of meters. But I need to convert to something I'm familiar with because I know that 1 inch is 2.54 centimeters. So I want to get to centimeters. So I need one more conversion factor because I know that there are 100 centimeters in 1 meter. Okay. So at this point, I have units of centimeters. See, I'm not worried about the numbers right now. I'm just looking at my units to make sure that I've set this up properly. Okay. Then finally, since I know I need to get to inches, okay, the final conversion factor is 2.54 centimeters in 1 inch. I set it up with centimeters in the denominator because I want centimeters to cancel, leaving me with units of inch. And now remember, all of these are exact. This is an exact factor, so they will not play a role in my sig figs. I got 3 sig figs here. My answer should be written with 3 sig figs. So in 3.54 times 10 to the negative 3rd kilometers, there are 139 inches. Okay. All right. 139 inches. So, 2-liter bottle soda contains how many quarts? So we're going from liters to quarts. All right. We write down what we're given, 2.5 liters. All right. I know there's from the conversion factor quarts to milliliters or English to metric. I know that in 1 quart, there are 946 milliliters. So I can take my 2 liters, convert that to milliliters. And then once I'm in milliliter units, now I can convert that to quarts. So my first factor converts my liters into milliliters. Okay. And then my second factor converts the milliliters into quarts because that is the units that I'm striving for. Okay. Now, here, 946 is not exact. It's 3 sig figs, and 2.0 is 2 sig figs. So my answer should have no more than 2.2 sig figs. So the answer is 2.1 liters. All right. Now, the point of this chapter exercise is to set up the conversion factors properly, okay? Because this is going to be tapped into the ultimate goal is when we get to calculations down the road. We're going to be using these types of conversion factors, okay? So try not to Google your conversion factors. Just use the conversion factors we give you. Sometimes the Google numbers are off. And again, the answers that are given, because remember that these are measurements. Some of these are measurements, okay? So there's a degree of uncertainty at the last number. And we try to incorporate that degree of uncertainty with respect to Canvas. Canvas is definitely not AI. It's not a very smart cookie. It's got to know all the possible answers. So if your answer is you think it's correct based on how you set that up, but Canvas treats it wrong, shoot me an email. I'll be glad to go in there and work through the problem to make sure you set it up properly. And if it is correct and you're off just a little bit, I have no problem giving you credit for it. But I think if you just use our conversion factors, you and Canvas will be happy. All right. All right. Do practice some of those problems. There's again the worksheets. There's a lot of problems about that, and you can also make up your own problems. And if you can bring in the class and we can work them. Next Tuesday, the exam time period. Like I stated, we will continue with the chapters unless you have questions. You haven't taken the exam yet. Questions about certain problems. That's a good time to bring them in. We can go over them. Okay. All right. So with that being said, we have here what we call volume by displacement. Now, why do we want to do this? We're going to eventually talk about density. In density, we kind of briefly touched it. It was a ratio of mass over volume. Okay. Now, a lot of things, the mass for any chunk of matter is easy to obtain. We just weigh it. But the volume can be a little bit more difficult. If we have a container that's rectangular shape, we can easily measure it, length, width, and height. We got the volume, we're good to go. We weigh it, we got the mass. We tap in those numbers in the calculator, and we got the density, right? However, there's certain things that we cannot measure the volume directly. Like this pen, for example, it's difficult for us to measure our particular volume, but we can obtain it by a different method we call volume displacement. And so if you were to jump into a container of water, we all know that volume will go up because your body displaces the volume of water, so the total volume goes up of that container. Now, if we know the volume to begin with before you jump in the container, okay, and then you go in there, you completely immerse yourself, get under the water, the volume goes up, and if we mark that amount, that difference is the volume that you displace, okay? That's the important part. If you start off with, say, 100 milliliters of volume, and you put something in, and it brings it up to 130, that material did not have a volume of 130, okay? That's important. The difference of where it ended minus where it started, that is the volume of that material, okay? So this is what this is talking about here. So now using that example for your body, you know your volume now, we get your weight, now we can measure your density, okay? So if you take a diamond and we put it into a cylinder, a graduated cylinder is basically, it's a cylinder. It has markings on it that gives, we can measure the volume. Okay. So if we start off with 20 milliliters of water in that cylinder, and then we throw a diamond in, the volume increases to, the new measurement is 34.7, because that diamond displaced that amount of volume. That difference is the volume of the diamond. Okay. And so that volume, excuse me, that diamond has a volume of 147 milliliters, not 34.7. Okay. That's the total volume that displays. Remember, it's the difference between where it ended minus where it started. Now, if you get that diamond and measure its volume, its weight, its mass, guess what? We have a density. Okay. All right. So as we stated here, okay, carbon, we know about that. We'll come back to that. Now, if we have something that's regular in shape, we can measure its volume by simply length times width times height. So we have a shoebox, measures 24 centimeters by 11 by 16. You plug in the numbers in the calculator, keep track of your units. Centimeters times centimeters is centimeter square, times centimeters is centimeters cube. Banana times banana is banana square, times banana is bananas cube, times banana is bananas to the fourth power, times banana is bananas to the fifth power. Okay. All right. So what we have here is volume cube. If we only did one length, that would be the area, square centimeters, but we're doing all three dimensions. So we got the volume of this box is 4,200 cubic centimeters, or cc's, remember that? Or how many milliliters is 4,200 cubic centimeters? Anybody know? Okay, 4,200 cc's. How many mLs is that? (4,200 milliliters). Just remember, 1 cc equals 1 ml, milliliters. All right, good. All right, so density, as we stated before, way back when, is a ratio of mass per volume. Hey, key word, ratio. Remember what I said about a ratio? Keep that in mind, because you can write this density as volume over mass, or mass over volume, if you need it to do calculations. Okay. All right, well, I tell you what, we are on chapter 3. Write this down. And we're going to stop it here on 15 because it looks like I got 1 minute. Okay, so we're going to stop it here. From Thursday, we'll finish it up. It doesn't take much more. They're very short problems. We talk about density, we'll do some more calculations, and we'll be done with chapter 3. Okay, so let us stop it here.